So I was out hiking the other week and I heard this sound. It was this loud, hoarse bark echoing through the woods.
A dog, you thought.
I was sure it was a dog, but then I saw it and it was this tiny deer, maybe the size of a Labrador, just staring at me.
Ah, you had a classic Muntjac encounter.
Yeah.
The barking deer.
Yeah,
That's what we're getting into today, and believe me, it's a creature that seems almost mythical.
it really does. So that's the mission for this deep dive.
Yep.
Unpack this animal with its strange bark, its fangs.
And what's really wild, it's absolutely staggering genetics. It holds a biological record that is just, well, mind-blowing.
Let's start with the basics. They're small, right? They look tiny.
Oh yeah, they're diminutive. We're talking about 50 centimeters high at the shoulder, maybe 10 to 18 kilos. They have this kind of stocky, hunched-over build.
Which is perfect for
What?
hiding.
Exactly. For moving through the really dense forest undergrowth where they live, mostly in places like China and across Southeast Asia.
And that bark I heard, it's their signature, I take it.
It is. It's an alarm call. When they spot a predator, a fox, or in their native range, maybe a Temminck's golden cat, they'll start this short, sharp barking.
And it can go on for a while, I've read.
It can. Up to an hour, sometimes even more. It's incredibly effective communication.
Okay, so we have the bark, but the thing that really gets people are the fangs or tusks.
Right, the fangs.
Yeah.
They're actually elongated upper canines. In males, they can be up to, 5 centimeters long?
But they also have antlers. So why both? It seems a bit redundant.
Well, the antlers are quite small and simple. They're more for display, for a bit of shoving. The canines, though, those are the real weapons.
So how do they fight?
They'll lock antlers and push, but if one gets the other off balance, it's all about those tusks. They'll try to slash at the face, the neck, the rump. They're like little daggers.
And because they're solitary animals, I assume they have other ways of communicating.
Oh, absolutely. Scent marking is huge for them. If you look closely at one, you'll see these very prominent V-shaped glands right below their eyes.
The preorbital glands.
Exactly. They're constantly rubbing those on trees and shrubs, leaving these really complex messages for other muntjacs.
Let's talk about some of their other extremes. Their diet is, well, it's not what you'd expect from a deer.
No, not at all. They're mostly browsers, eating leaves, shoots, fruit, but they're also opportunistic omnivores. Meaning they've been known to eat bird eggs and even scavenge on carrion if they find it.
Wow. And their reproduction is just as intense, right?
It's astonishing. The females are almost perpetually pregnant. After about a 7-month gestation, they give birth, and then they can breed again almost immediately. The fawns themselves can breed at just 6 months old.
That kind of rapid biological cycle, that efficiency, it just screams complexity. Analyzing biological data that changes that fast, it's a huge challenge.
It's a massive one.
It actually reminds me, this deep dive is supported by Silk. If your business is dealing with complex data and you need help turning it into real strategies, whether it's AI training, automation, or software development, Silk has that expertise.
They help you find the intelligence in the noise.
Exactly. So if you're trying to uncover where high-impact AI agents could help you, check them out at embersilk.com for your AI needs.
And genomic efficiency is the perfect phrase for where we're going next.
Ah, the chromosome mystery.
Yes. So let's take the rhesus muntjac. It has a pretty standard chromosome count for a deer. 23 pairs, so 2n46.
Right. Normal. In the ballpark for a mammal.
Exactly. But then you have the southern red muntjac. The female of that species has the lowest diploid chromosome number ever recorded in a mammal.
And that number is?
6.
Wait, 6 total. Down from 46?
6 total chromosomes. The male has 7. It's a spectacular reduction. And it happened because of an incredibly rapid of what's called chromosome fusion.
They just merged together.
Essentially, yes. Over evolutionary time, dozens of smaller chromosomes fused into these few, massive, hypercondensed ones. The rate of this change is thought to be like 10 times faster than in the average mammal.
So it's like taking a whole library of books and condensing it into just a few volumes.
That's the perfect analogy. And here's the truly hopeful part. Despite this radical genomic reorganization, the species is a huge success. It's thriving. It shows that life can undergo these massive internal changes and not just survive, but flourish.
That's incredible. It sort of challenges our whole idea of how stable a genome needs to be.
It absolutely does. The Muntjac proves that there's this amazing genomic plasticity, this resilience that allows for radical, successful new paths in evolution. It makes you wonder what other potential is locked away in the code of life that we just don't understand yet.
What a fantastic thought to end on. If you enjoyed this deep dive into this barking, fanged biological marvel, please subscribe to the show. Hey, leave us a 5-star review if you can. It really does help get the word out. Thanks for tuning in.